Okay, so if you have an absorption issue, you know, a lot of people we see, they are trying to fix their soundproofing issue by adding absorption panels. And there's a lot of, you know, sadly enough, kind of predatory marketing out there of, can you hear your neighbors, you know, add panels in your room? That is absolutely nothing for sound transmission. Absorption helps with echo or reverb control. So that's if you're in a church, a courtroom, a clubhouse, you know, a large open municipal area, a large room, you're going to get a lot of reverb in there. And here's how we calculate. It's called the Sabins formula. There's a number of other approaches, the airing formula, for instance. But basically, it's the volume of the space divided by the acoustically treated area of the space. Okay, and every product has an acoustic treatment rating, and we call it the NRC. So here's a brief Excel kind of overview of it. There's a number of software systems that do it as well. For the Omni Convention Center, a small room in there, 39, well, a medium-sized room, 39 by 25 feet with 12-foot ceilings. One wall had a foldable partition. 3 other walls had drywall. The flooring was carpet with pad, so a good NRC there of 0.25. And then the ceiling was a composite, half drywall, half ACT. So we blended the NRC of those two products as a 0.2. Okay. So these finishes have these NRCs, coefficients of absorption. And then the area of each of these finishes is based on the geometry. You put all that together and you say you have 646 square feet of treatment in the space. And going by this formula, 0.05 times volume divided by your treated surface area, you have a reverb time of 0.9. Okay, this is a little bit more complex than your target STCs. It's a 2-part formula basically, but you get your area of each space multiplied by the NRC of that surface or that finish, and you add all of those up to get 646. This formula has a lot of limitations. It's assuming a rectangular prism. It's, you know, very few rooms are like that. But you know what? This Omni Convention Center room was just like that. So, you know, it was actually a pretty good deal. And rectangles are probably the most common of any, you know, area, any room type. So it is applicable, but you can't rely on it solely. Is 0.9 good? Is that a good reverb time? It depends. Okay. In our handbook, we greatly expand on this chart, but for recording and broadcasting studios, a 0.9 would not be nearly acceptable. The amount of echo and reverb in that recording would be unbearable to people on the other end of the line. If you've got telecoms going on, if you have a classroom, you know, kids have a really hard time understanding, kids, adults, whoever, educational settings need about a 0.6 to 0.8. A 0.9, somebody sitting in the back of the classroom with that much reverb would have a lot of difficulty understanding the teacher. Even somebody sitting in the front of the classroom would still have quite a bit of difficulty. Whereas for restaurants, and that's a huge complaint here, anywhere from 0.6 to 1.0, depending on the intimacy or the casualness of the restaurant. Fine dining, you want low reverb. For casual or like a sports bar, we've actually seen like a 1.2 or 1.3 is actually acceptable. You never want to be above a 1.5 for almost any reason. Churches and cathedrals that rely on organs and, you know, they want reverb for fullness of the sound, then it makes sense. But even multi-purpose situations, you still need some reverb control or nobody in that room is going to be able to hear the speaker. Lead version 4 also gives us a number of those targets. Meeting and banquet rooms, 0.8. Office rooms, telecoms are a huge issue nowadays, 0.6. So if you have an office or a conference room that has hard floors and hard ceilings, you cannot have a telecom in there without some level of acoustic treatment. And that's almost regardless of the size of the room. I've seen very few where you could have a telecom on speaker and not have a ton of feedback on the mic. And then once you get into bigger conference rooms, even with ACT and carpet on pad, you still need reverb control. So it's a product of both your geometry, the size and height of the room, and the finishes, and that's what tells you how much reverb you're going to have. And then by this definition, how much reverb is acceptable. Just, you know, a good visual of what reverb control looks like. There's a lot of applications people are familiar with. There's baffles. These are all echo eraser products. That's our kind of in-house product that we manufacture here in Tampa. There's a lot of other products on the market. There's Tectum, you know, soundscapes and all kinds of stuff, but you're looking for the NRC of each of these. These are all 2-inch thick, 6 pound per cubic foot fiberglass, very high end, very effective sound absorption products. You can go with a Zintra or a Tectum, which has an NRC of like 0.4, basically no better than carpet or ACT. But if you get enough of it and it's the right aesthetic, then it can do just as good of a job. It just depends on how much you have. It's a very expensive way to get there, but also they make a really good looking product at the same time. So, you know, if budget's not a major constraint, you can go that route. You can custom color the panels like mellow mushroom. These are all aftermarket options. So if you get somewhere and it's too noisy, you can go fix it afterwards by custom coloring panels or mixing it into the aesthetic. You can never fix soundproofing, the part that I mentioned up front. So, and these are very different things. Absorption and soundproofing are kind of polar opposites, if you will. It's much more economical to do this stuff up front, though, of course. So based on Sabins calc, with corrugated metal deck, sealed concrete floors, windows, glazed walls, and then painted CMU, this room needed a lot of panels. You can go with clouds, but if you have sprinklers overhead, that becomes a constraint as well. So you have to be above the sprinklers, or you can just be on the walls. Churches oftentimes require this kind of product. See, even with carpets and ACT, they still had a ton of complaints hearing the pastor, and that's because the room geometry was too large. Moffitt Cancer Center, we use fabric walls for a lot of kind of our high-end commercial clients. It's a very common aesthetic that they prefer. And how do you as an architect or a spec writer, how do you specify this type of product? Okay, generally, one thing is don't put it in the 095100. Are they always placed high on walls? Thank you, Melton, for that question. No. We do have rules of thumb for placement. It's a major, we see it all the time with like end clients. Well, if we put it here and here, can we get by with fewer panels? There's an area effect that is correlated with the efficiency of the panels. And basically it's saying the efficiency is proportional to the perimeter of the treatment over the surface area of the treatment. So if you space out those panels a lot more, you'll have a wider perimeter around all of them. But the surface area of the treatment doesn't change. You're not changing the number of panels or the size of the panels. You're just spreading them further apart. So we do place them up high for a number of reasons. They don't get dirty as quickly. These are fabric, and there's a number of different options. There's a lot of, actually, here's your primary fabric options. And these are all on our website. Oops, there's the 11-page spec for that CA approved assembly I was showing you earlier. And you can see that the STC does change based on the stud size. And this is a 49 and a 50. But for specifications, we have these available at 3-part specs in Word version. And these are the common fabrics we see. It has to be an acoustically transparent fabric. So it can't block the sound from getting into the fiberglass, because the fiberglass is what's absorbing the sound. If it's a Zintra or a Tectum, that's more of a compressed polyester, but regardless, it's a soft, porous material that's absorbing the sound. And the fabric's just letting the sound through into that product. Guilford of Maine is kind of the industry standard. They have some washable types of fabrics. And if you use washable fabric, then you don't need to place it high on the walls. But if you're using an FR 701 or an Anchorage fabric, or certainly any kind of Carnegie fabric, some really expensive, $40 to $60 a linear yard, then you will definitely want to place them up high enough where they're not going to get damaged and dirty. The other thing is these are all made by hand. None of them are, machine made. So generally there's some imperfections with panels. Getting them away from eye height, even if it's just a few feet up, makes a difference of you don't see minor imperfections. And then the other thing is kids bumping into them or kind of damaging the actual under the substrate fiberglass. One thing we use for that is what's called a 1/8 inch impact resistant layer. Very common in gymnasiums or sometimes conference rooms where the chair, instead of a chair rail, you've got acoustic panels around the perimeter. If you bump into one of these with a chair rail, that could be that could damage and leave it a permanent dent. So you can use impact resistant layers. Be aware that will affect the NRC. So for these products, the NRC is 1.05 for a 2-inch product and 0.8 for a 1-inch fiberglass. You want to make sure when you're speccing, it's a 6 to 7 pound per cubic foot fiberglass. The 3 pound is very mushy, and it will, when you wrap it with fabric, the edges will not be very rigid. They won't be perfect 90-degree angles. You can get, beveled edges or chamfered edges or half rounds. You can require resin hardening edges. So this is the spec for our Echo Eraser, just part of the 3-part spec. But you can kind of see, hey, here's what I want. I need 2-inch, I need high impact, I want it resin hardened. And then you can design the fabric based on these huge galleries of fabric options.